Example 4.
Find the derivative of arc sine of 2x with respect to x. So first of all, remember that when we're taking the derivative of arc sine of u with respect to x, where u is any function in terms of x, the rule is it's going to be u prime all over the square root of 1 minus u squared. So we need to apply this rule to this derivative. So u is 2x. So first of all, we're going to take the derivative of 2x, which would be 2, all over the square root of 1 minus u squared. So 2x squared would be 4x squared. So it's really not too big of a deal as long as you remember the rules, so memorize those. B, for this one, we're looking at the derivative of arc tangent of u with respect to x. This is going to be u prime all over 1 plus u squared. For this problem, u is 3x, so the derivative of 3x is 3. All over 1 plus u squared, u is 3x, so 3x squared would be 9x squared. Part C. Part C, again, we're going to use the rule that we used in Part A. So I'm going to rewrite the square root of x as x to the 1/2 power. So when I take the derivative of x to the 1/2 power, that's going to be 1/2 x to the negative 1/2 power, all over the square root of 1 minus, if I square the square root of x, that's just going to be x. So now I have 1/2 all over, I'll bring down x to the 1/2 times the square root of 1 minus x squared. This would be 1/2 all over. If I think of this as being a radical and multiply it through, this would be x minus x squared. And then from here I can multiply the numerator and the denominator by 2, giving me 1 over 2 times the square root of x minus x squared. Part D. For Part D, the rule is going to be the derivative of arc secant of u with respect to x is going to be equal to u prime all over the absolute value of u times the square root of u squared minus 1. Where for this problem, u is equal to e to the 2x power. So u prime would be e to the 2x times the derivative of 2x, which is 2. So this one's going to be 2e to the 2x. So now let's just plug this into the rule here. So u prime is 2e. Let's do this over here. So let's write this as the derivative with respect to x of arc secant of e to the 2x would be equal to u prime, which is 2e to the 2x, all over the absolute value of u, which is e to the 2x, times the square root of u squared. Well, u squared would be e to the 2x times e to the 2x. When you multiply like bases, you add the exponents, so this would be e to the 4x, so e to the 4x would go here, plus 1. Alright, let's look at example 5. Example 5. So the derivative here, y prime, well, we know the derivative of arc sine of x is going to be u prime, so that's going to be the derivative of x, which would be 1, all over the square root of 1 minus u, where u is x, so this would be x squared, plus, notice here, this is the product rule. So you could think of this as x times 1 minus x squared to the 1/2 power. So this is going to be the first function, which is x, times the derivative of the second function, which is 1/2 times 1 minus x squared to the negative 1/2 power. And then you have to multiply by the derivative of the inside function. This is the chain rule, so this would be negative 2x plus the second function times the derivative of the first function, which would be 1. Okay, so now I've done the derivative all the way through. Now I need to simplify everything. So I'm going to write this as y prime equals 1 over, I'm going to write this in exponential form, so 1 minus x squared to the 1/2 power. And then here I need to multiply 1/2. So 1/2 times negative 2 is negative 1. Negative x, so this would be negative 1x times x. That's going to be negative x squared. And then you still have 1 minus x squared to the negative 1/2 power plus 1 minus x squared to the 1/2 power. So now I have that. Then let's see if I can come up with a common denominator. 1 minus x squared to the 1/2 power minus, I'm going to write this as x squared, and since this is a negative exponent, I'm going to bring this down here and make this 1 minus x squared to the positive 1/2 power. And then if I want this to be 1 minus x squared to the 1/2 power, then I have to multiply the numerator by 1 minus x to the 1/2 power as well, because that's the same thing as multiplying it by 1. So we know the denominator is going to be 1 minus x squared to the 1/2 power. When I multiply these together, they're like bases, so we're going to add the exponents. That would be the first power. So this would be x minus, or 1 minus x squared to the first power, which you don't need to write. Now I can add and subtract, I can combine like terms. So the numerator is going to be 1 minus x squared plus 1 minus x squared all over 1 minus x squared to the 1/2 power. This would become this would become 2 minus 2x squared all over 1 minus x squared to the 1/2. Then you could factor out a 2 and have 1 minus x squared all over 1 minus x squared to the 1/2. Now look, you have like bases. When you divide like bases, you subtract the exponent, so this would be 2 times 1 minus x squared to the 1/2 power.